Okay, so this is the do now that I asked you guys to do. Um, the question is, what is the difference between enthalpy of vaporization and enthalpy of condensation? Enthalpy of vaporization is the energy needed to change a liquid into its gas phase. Okay, and normally the enthalpy would be positive. It would be endothermic because you need to invest energy to change it from a liquid to a gas. Condensation is the opposite. You're going to release energy in order to turn something from a gas to a liquid state, like rain is an example. Today's agenda is this. We're going to finish the notes on phase diagrams, which you should already have. You might have to draw things in into your notebook, so make sure you're following with the notes that you already have pasted in your notebook. If you don't have them, then you need to get them from the absent binder. You're also going to complete questions 8 through 17 on this page. They should already be on this page of your notebook, and then you're going to have the rest of the time to work on your science night project since it's due Thursday of next week during math and science night. So the main question here is, how are pressure, temperature, and phase, how are they related? For example, we have solid, we have liquid, we have gas, but how do they change when it comes to a certain pressure or a certain temperature? The state of matter of a substance really does depend on temperature and pressure, as we're going to see in a bit. This is called a phase diagram. So what I would like for you to do is to go ahead and pause this and copy it down in your notebook, and then I'm going to go over it in a bit. So go ahead and pause. Okay, now that you pressed play, I'm going to teach you how this is read. So it's kind of read like a book. You read from left to right. On the left side here, in this region right here, we have what we call the solid phase. So we have solid all over here, all of here. We have solid, solid, solid. So if I put my dot here, for example, or I have a region that I'm analyzing here, at this pressure and this temperature right here, you have a solid. So depending on the pressure and temperature, you could have a solid. Then let's say we're at this pressure right here, and then we increase the temperature to the right, then we enter the liquid phase, the liquid region. But then if we drop the pressure, we could go into the gas phase. So typically gases exist under very low pressures, and we typically have liquids and solids at high pressures, because at high pressures the particles are more squashed together, they're more compact, they're more compressed. So it makes sense that the liquid and solid phase tend to exist at high pressures. So just know that the solid is here, then the liquid, and then the gas tends to be down here. The critical point is this point right here, which we'll talk about later. And the triple point tends to be right here. It's the part where all three of these lines intersect, and that's called the triple point. The boiling point is right here. Depending on the pressure, it's probably right here. Here would be the melting point, which we'll talk about later. Before we get there, I need you guys to label your phase diagram like this. So if this is the solid phase, let's say this is the solid. Oops. If this is the solid right here and this is the liquid, when we go from liquid to solid, like water to ice, we call that freezing. When we go from gas, so all of this right here is gas. So when we go from gas to liquid, that is called condensation. For example, clouds are gases and they turn into liquid. And when we go from gas which is also in this region here. When we go from gas to solid down here, we call that deposition. So this is probably new to you. You already learned about freezing, you already learned about condensation, but you probably didn't know what deposition was. Deposition is when you go from gas straight into solid, like hail, for example. It's in the clouds, and then out of nowhere you feel these chunks of ice just hitting you. That is called deposition. Then we go the other way. Let's say we increase the temperature. If we go from a solid to a liquid, that's called melting. Another word for this is called fusion. And when you go from liquid to gas, that is called evaporation. And when you go from solid to gas, that is called sublimation. So make sure you understand the meaning of these words. Add them to your flashcards if you don't already have them. So melting, again, here to here, liquid to gas is vaporization, but then this weird one, solid to gas, like dry ice, for example. The solid, dry ice is a solid, but then it turns into steam, which is a gas. It skips the liquid phase. So that is called sublimation. Something sublimes, it's turning from a solid to a gas. Air fresheners, for example. Those solid ones, they release smell, right? Chemicals in the air, particles are moving in the air that make the room smell nice. Those are technically gases that form because their particles are moving into the air. We call them a gas. And that is another example of sublimation. So at the very beginning, we labeled a point as the triple point. Right here, for example, this is a different phase diagram. This is the point where all three phases coexist. So you have a solid, liquid, and gas. All three of them tend to coexist at this pressure and this temperature down here. All three phases coexist. The critical point is a point where you have a high temperature and high pressure, but this is the point, a very critical point, where you have both the gas and the liquid coexisting. For example, at 374 degrees and at this unknown pressure here, we have the critical point, and that's the point at which the pressure and temperature coexist. So here's just a summary of what we learned so far. Just know that the solid is here, then the liquid, and then at low pressures we have the gas. Know the processes going from one area to another. So solid to liquid is melting, the other way around is freezing. From liquid to gas is vaporization, the other way around is condensation. And then know these two weird ones that are probably very different. Sublimation, going from a solid to a gas like dry ice, and then depositions the other way around. Know that the triple point is where all three phases coexist, and the critical point is where the gas and liquid coexist. So make sure you understand how to read that. Here's a class example. So let's see if you guys could do this on your own without even listening to the podcast yet. So go ahead and press pause. Okay, now that you tried, here's the class example. It says you have a solid at a pressure of 30 atmospheres. So atmosphere is a measurement of pressure. Here's 30. And negative 15, which is right here. So right here at this point right here. So let me just draw that in. So right here, let me see if I could draw like a little square at least. It's not, doesn't want to. Okay, so somewhere around here, in this box right here, that is where you have 30 as your pressure and negative 15 as your temperature. This region right here. It says if you could decrease the pressure at constant temperature, so that means you're going up and down because that's what pressure is changing. It says there's a decrease in the pressure at constant temperature, so we're going to keep the temperature at negative 15, meaning that we could only move up and down. It says what will happen to the phases if we go down, if we decrease the temperature. So first of all, we're at C, we are at the solid phase, and then as we go down, we are going to be touching the triple point where all three phases coexist, and then we are going to go into the gas phase. So our answer is going to be that what are the phases that undergoes? We're going to say it goes from the solid to the triple point to the gas phase. So we didn't touch the liquid phase at all, region B. So that's your answer. So with that said, see if you could try this one. Go ahead and pause it, then start again. Alrighty, so let's go over the answer. The atmospheric pressure of Mount Everest is 0.29 atmospheres. So 0.29 is probably somewhere, let me copy this guy from the previous slide. So negative 0.29 is probably right here somewhere. And it says, what is the boiling point of water? What is a boiling point of water using the phase diagram below? So the boiling point, we know that's the temperature at which it goes from a liquid to a gas. So at this pressure, we're going to go to the right because it's constant, the pressure is constant. And it's a liquid, so at first it's a solid, it's a solid, it's a solid, it's a solid, it's a solid. Oh, now it turns into a liquid. And then the boiling point would be right here because it's starting to turn, it's trying to go from the blue region to the beige region. So the boiling point at that specific pressure is going to be right here, which I would probably argue for it to be 40 degrees Celsius. So somewhere around 40 degrees Celsius. So that's what my answer will be. The normal boiling point at 1 atmosphere tends to be here at 100, but that's not what the question asked for. It asked for the boiling point at this pressure, at Mount Everest. As you move up the mountains, the pressure tends to drop. Alright, now that we're done with that, with the lecture, I want you guys to work on the heating curves questions 1 through 7. Make sure you're not going to get a stamp because I'm not in class. And then work on your science night project. Okay, make sure that you get a lot of it done because that means that it's due next week on Thursday. And we're not gonna have time to work on this in class next week. That much. So please work on it and be serious. Okay.